Lawrence Ortner. I'm Warner's Technical Support Manager, and this is video 2 of 3 of the companion videos to the Logix 5000 intro class. This video covers the labs that deal with importing tags as well as creating some basic bit logic. First thing I'm going to do here is import some tags from a CSV file, demonstrating that we can reuse work that's been previously done. So in this lab we're going to import some tags. First let's take a look at the tags as they are. I'm online with my controller and we can see some local tags here representing the input and output for the I/O modules, as well as other tags that were created previously. I'm going to go ahead and import some tags. Under the Tools menu I can choose Import, but you can see that's not enabled right now because now we need to be offline to import tags. So I'm going to go offline and do the import. We have some options here of what should happen, or what the software should do when we're perhaps importing a tag that's the same name as a tag that already exists. You can see the tag database list has expanded greatly. We've imported about 25 tags, and those tags will be used throughout the logic later. Since we've done this offline, to get it back into the controller, I'm going to do a download. I'm going to go ahead and put the controller back into run mode. And we're going to look at these tags just a little bit more. The tags that we imported were created to be aliases to real-world I/O. And when I switch over to the Edit Tags tab, we'll see that DO0, a tag that we named DO0, is actually an alias to local:1:0.data.0. This allows us to name a tag as we wish, and in this case it matches the actual engraved label on the demo unit, and that tag is then related to an actual real-world tag, local:1:0.data.0. And you can see that pattern is followed throughout the input tags and the output tags. I'm going to switch back to some of the logic that was already in my controller. In the main routine, there was a handful of rungs of logic, and we'll see some tags in here named things like DI12 placeholder. That was a temporary tag, again demonstrating that you could write logic in these controllers long before knowing where the I/O modules would be in the controller, and then come back later and replace those tags with the actual I/O tags. So to do this replacement, I'm going to double click on the rung and replace that DI12 placeholder with the new tag DI12, just typing over top of it. We can see that it brings along the alias information. I'm going to go through each one of the rungs here that has an I/O tag in it and do the replacement that's indicated. DO0, starting the rung edit by double clicking and double clicking again, and DO1, and we have a couple of more here, DO4, DO5, and I think we're down to just one last one. There it is, DI0. Each one of these rungs have been edited, and we can see that the rungs are labeled with either a lowercase I or a lowercase r, indicating that the one rung will be inserted and the other being replaced. Lowercase means that so far that rung is not even in the controller, but we have a button here to finalize those edits, which will put the edits into the controller and have them execute. So now we can see real-world inputs in front of our rungs of logic. The fourth lab that we do in the class involves typing in some of our own bit logic. In order to type that bit logic in, I'm actually going to create a new routine for it. So here underneath Main Program, I'm going to choose Add and New Routine. I'm going to call it Bits. And when I double click that routine, we see an empty rung of logic that we can add our own logic into. Of course, there's a variety of ways of typing logic into the software, but I'm going to use the simplest here of click and drag rungs in. I'm putting in some fairly meaningless logic just for practice in entering the logic. We'll have plenty of time during the class to practice that yourself. Once the logic is on the rungs, we need to identify the tags that are going to be used, such as DI0, DO2, DI1, 2. Each of these represents a digital input on the demo unit or a digital output. And again, since we're doing this work online, we need to finalize these edits to actually get those rungs into the controller. You may have noticed that these rungs are not highlighted in green here, meaning that that controller is not executing these rungs of logic. We need to add a new rung in order to have these rungs execute, and that is a JSR. So back to the main routine, I'm going to add one new rung at the very beginning, add a JSR, a jump to subroutine instruction, and ask that instruction to jump the routine, jump the execution of the routines over to the bit logic. And when I accept that edit and switch back to the bit logic, we can now see the green power rails, and we can actually see our logic executing. For example, DI0 corresponds to the push button on the demo box, and when I push that one, the rung becomes green, the output turns on, and the red light turns on. That corresponds to digital output 2. And similarly, digital input number 2 will cause the second rung to come true, and output 3 turns on. If you have any questions about these videos or would like to sign up for one of our classes, please contact Werner Electric Supply.